welcome to all of you attending our exciting new Shop Talk Live virtual event. If you attended yesterday's sessions, welcome back. And if this is your first time attending, it's a pleasure to have you to join us today. As you can observe within our virtual platform environment, we're departing from the conventional webinar format.
We intentionally created a virtual environment that would be something new, different, and innovative. Through our new virtual Shop Talk Studio and 3D platform, we can exchange ideas that will deliver an exceptional and immersive experience. Following the event, we are thrilled to provide you with exclusive access to Shop Talk, our cutting-edge 3D platform available to you 24/7. Within this virtual space, you'll discover a wealth of opportunities to enhance your understanding of our technology solutions.
You can delve into various sections such as technology insights, where you can join and gain a deeper understanding of the innovations driving our industry. Take a tour of our state-of-the-art technology center, a virtual 3D workshop equipped with different workstations, offering you an experience like never before. For those eager to expand their knowledge, we offer a comprehensive collection of learning resources under online learning. You'll find that all the sessions from today's event will be recorded and made easily accessible, enabling you to revisit and absorb the value content shared by us. Should you have any questions or wish to connect with us, we've made it effortless for you. Feel free to utilize the Get in Touch form, and our team will be readily available to assist you.
In a nutshell, a wealth of valuable content awaits you within Shop Talk with Hypetham Associates Multi-Technology Solutions. It's our commitment to providing you with ongoing support and resources to help you succeed. Thank you for being part of our journey, and we look forward to empowering you with knowledge and innovation through this platform. Once again, a heartfelt welcome and thank you for being a part of this global gathering. Enjoy day 2 of our Shop Talk Live event.
Before we dive into the detailed program, let's be polite and introduce ourselves. The lady to my left is Ilana Rousseau. She's a Hypetham Associates Insights and Innovation Program Manager with 12 years of experience in the organization. She's responsible for collecting market insights, interpreting them, and driving them to actionable development opportunities to better meet customers' and partners' needs.
The gentleman next to me is Tim Seivright. He's a Hypetham distribution sales manager with over 20 years experience in the welding and cutting industry. He works to support all Hypetham Associates channel partners throughout the Sub-Sahara Africa region with their sales strategies and growth agendas on all Hypetham Associate brands. We are pleased to be your hosts for the Shop Talk Live event today.
Let's continue with a quick company introduction. You may not know this, but Hypetham Associates is a 55-year-old company and is 100% associate-owned, ensuring a relentless focus on customer success. We design and build cutting-edge industrial solutions, and when you interact with us, you're speaking directly to an owner. From engineering to service, our associates are dedicated to delivering the industry's top plasma and water jet cutting systems, backed by advanced software and services for maximum productivity.
Within the Hypetham Associates company umbrella, you'll discover the brands you're familiar with and trust. Our organizational structure illustrated here encompasses our technology brands, Hypetham Plasma, Omax Water Jets, as well as our software offerings, ProNest and RobotMaster, along with the aftermarket consumables, SentryCut and AccuStream.
Together with our valuable channel partners, we can be found supporting a wide variety of global customers, everyone from an individual artist to large advanced manufacturing operation in aerospace, agriculture, offshore and energy, and steel fabrication, to name a few. Here's a quick video showing Hypetham Associates solutions.
So, today you will hear about ways to reduce your carbon footprint, lower your costs, and how our software solutions can help you do that.
For today, we have several interesting and interactive sessions lined up on a diverse range of topics. Stay with us. We will dive into details shortly.
Tim, before we go over the event schedule, I'm really curious to see where the participants are logging in from. Therefore, I kindly request all attendees to participate in this fun activity. Now we'll display a world map, and we invite each of you to click the button and share your current location. Let's pause for a moment to give everyone the chance to share their location.
Yesterday, we had attendees from all over the world participating. I really hope that will be the case today as well. We will find out soon. Ilana, looking at the map, we've got a great presence. We've got people chiming in from Brazil, both the east and west coast of the US, Great Britain, India, the UAE, and Central Europe, and down in my home country of South Africa.
I see UK, I see some Scandinavia, looks like Finland and Norway or something similar. Great presence all over the world, really. Great to see all attendees. Let's quickly outline the Shop Talk Live event program for today.
Our first session for today is on sustainability and understanding the life cycle impacts of the cutting process, presented by Robin Tyndall, our leader of environmental stewardship team. You will learn ways to lower your carbon footprint and reduce costs and waste in your processes. She will share examples on how we do this at Hypertherm Associates as we work towards zero waste and how we can help you with your objectives through our sustainable product design.
Next, Ariane Vondergan, our product marketing manager for WaterJet, will show you how our easy-to-use WaterJet cutting software helps you design, program, and cut parts without secondary processing. Everything you need to reduce operator dependency.
After the first two sessions, you'll be able to attend the breakout session of your choice, so you can customize your experience. If you wish to attend more than one, you will be able to listen to the recorded session afterwards, so you will have access to all that you want to.
You can choose from one of the following topics. Learn how ProNest CAD/CAM software can maximize parts per plate and support your sustainability goals at the same time. This session will be available in English.
See the benefits of cutting with WaterJet: reliability, ease of use, increased efficiency, and lower operator dependency. These sessions are available in multiple languages, including German, Spanish, Italian, Polish, Romanian, French, and English. Then, we will all be back together for a group discussion based on the questions you submitted at registration. You'll be able to interact with industry experts to discuss your toughest challenges, concerns, and get answers to the questions you want answered most. Let's begin.
Get ready for the Let's Talk Sustainable Path for Shaping Manufacturing 4.0 session, where Robin will delve into the impact of cutting processes on the environment and share insights on how to reduce your carbon footprint and costs.
Thank you, Ilyana. Good afternoon, good morning, and good evening, everyone. My name is Robin Tyndall, and I am the Environmental Stewardship Team Leader at Hypertherm Associates. I joined Hypertherm 13 years ago and work every day alongside all associates at Hypertherm to fulfill our triple bottom line mission, a mission to benefit people, planet, and profit. Part of our recipe for success is to reduce the environmental impact of everything we do. The industrial sector of the world economy has a huge environmental impact, and along with that huge impact comes a huge responsibility. For the past 14 years, we've been on a journey to understand our own environmental impacts, and we've begun working to reduce those impacts across our entire value stream. Our goal today is to share some of what we have learned to help you in your journey. I hope you'll come away with some specific actions that you can take to be a more sustainable business. I'd like to start with a quick poll. The question is, what do you think is the best way for your business to reduce your environmental impacts? A, reduce your electricity use. B, reduce your hazardous waste. C, reduce your scrap for cutting and shaping processes. D, reduce your highest impact raw material. Or E, reduce the impact from your products. Now let's see what people are saying. Looks like there's definitely a lot of interest in electricity use. And now I'm seeing more come in for reducing scrap. And we'll stop there. So I'll definitely be touching on these issues as we go forward. I do have good news about your sustainability journey. You're already on it, even if you don't know it. I feel confident in saying this because, like me, many of you are probably attracted to a career in manufacturing because you like making real, tangible, useful things. You can see and touch the results of your work, your raw materials, your processes, and your products, as well as your waste streams, are visible and tangible. Manufacturing professionals love solving problems, and I bet that you all probably use a variety of lean practices, either formally or informally. And lean is green. That's the good news. It's perfectly suited to helping you solve sustainability challenges. Let's pause for a minute again, and I'm interested to hear from you all. Type into the chat a word or a phrase that describes something that you do that's lean. All right, I'm seeing some people say relentless pursuit of waste. That's a good one. Efficiency as well. So as part of lean, we recognize the need at Hypertherm to go to the Gemba, which means to go to where the work is being done. In looking to lean out our value stream, from wasting raw materials to dealing with byproducts to reducing the time to unpackage components we use in our process, we went to the people in the cell who have their hands on this work. And when we went to them, not just with a question about how to be lean, but we incorporated a sustainability goal of reducing our use of electricity or fuel or raw materials or packaging. We connected to their values and aligned with something that engaged and excited them. We designated a green champion for every one of our teams, whether on the factory floor, the office, and for remote teams. These champions acted as an ambassador of sustainability work, bringing new topics and education from our central team and running projects to reduce energy waste and carbon within their expertise, as well as to bring ideas back to our team. One of the most impactful yet unintended side effects of our environmental stewardship journey is that our associates feel proud of their stewardship work. They feel empowered to take action that benefits the planet. This layer adds additional purpose to their work beyond making a quality product. Having purpose is something that not only engages and retains the great people that we have, but it also helps attract new talent. So with this lean lens to your work, what do you do first? Some examples of the first projects that we tackled were in things that were right in front of us. Our waste streams were the most obvious opportunities because we could see the actual piles and volumes of cardboard, shrink wrap, static bags going out the door as waste, and we could also see the wasted time that was needed to move that material. We needed to create partnerships with our suppliers to co-develop returnable packaging that was safer and easier to open, used empty return trucks back to the supplier, and vastly reduced the volume of disposable packaging waste that needed to be handled. We also created an unusual partnership with our waste hauler in which we loaned them a building to use for consolidation of waste materials from over a dozen other area businesses nearby. This allowed them to build full truckloads of single commodity material that recyclers were willing to buy, and helped all members of the partnership divert more waste from the landfill. And of course, we needed associates who were experts in each of the cells to design and optimize the space for storing, sorting, and moving these waste categories. The associates of each and every cell, building, or office area are also responsible for performing waste audits. And let me tell you, there is no better opportunity for hands-on education than going through your team or cell's waste bins to see the candidates for elimination, reuse, compost, or recycling. I'd like to hear from you all again. Put into the chat, have you done a waste audit already? And if not, what scares you about doing a waste audit? All right, keep those answers coming. Great. Now, some of the answers I'm seeing lead me to say, don't let the perfect be the enemy of the good enough. You have to start somewhere. Maybe you don't want to start with digging through food waste from the cafeteria, or certainly with bathroom waste. Leave those out and focus instead on your industrial processes, and I guarantee you, you will learn a lot. With these and other practices, we've reduced the landfill waste from our 12 headquarters buildings to under 1% and diverted 70 million pounds of waste from the landfill. Broadly speaking, we all need to think of waste as something first to be avoided and eliminated, but when it does exist, we then need to see it as a resource. Early wins in waste and energy efficiency are key to building momentum and enthusiasm for your initiatives. These early wins will create cost savings and be easy to see and easy to communicate across your organization. We replaced old lighting with new LED lighting that provided a brighter environment in which to work and also used less energy. Now, LED lighting is not new, but you can still seize this opportunity to show your commitment to efficiency and the fact that it can have a fast return on investment. Communicate those savings in dollars and not in kilowatt hours, because energy and electricity are invisible and therefore less tangible than waste. Measurement is really crucial here. We've gathered electricity and waste data that's specific to every area and function in our buildings, and that's also collected very frequently, usually every 15 minutes for electricity and daily for every waste stream. At Hypertherm, associates are tasked with finding the processes and equipment that use the most energy in their manufacturing cell and developing a project to reduce it. Compressed air is another perfect example of something that is energy intensive, yet invisible. So we've used measurement systems and equipment that allows us to see compressed air leaks with ultrasonic cameras that convert ultrasonic input into visual images of those expensive and energy-consuming air leaks. The first decade of our energy efficiency initiative, we avoided $3 million in energy spend. I'm going to transition now away from operations and toward product impacts, using our products as an example. I'd like to do another poll. What do you think is the best way for you to understand the environmental impacts of your products? A, use weight as a proxy as it indicates relative resource intensity. B, do a cradle-to-gate life cycle assessment. C, do a carbon footprint assessment. D, do a cradle-to-grave life cycle assessment. Or E, go through the certification process of a trusted third party. All right, I'm seeing a lot of votes right now for the carbon footprint. And I'd say second place looks like a cradle-to-grave life cycle assessment. A couple votes there for trusted third-party certification. Good, thank you for those answers. So actually, none of those answers are wrong, but a cradle-to-grave life cycle assessment, or LCA, is the best way to understand the full life cycle impact of your products, and then make informed decisions that will not result in an optimization in one part of the system that would actually make things worse for the overall system. A great example of this is an LCA that Levi Strauss did on a pair of jeans in 2007. The #1 climate impact of a pair of jeans was actually found to come from consumers washing their jeans. Though largely out of their control, Levi's embarked on a campaign to educate customers about using cold water, avoiding the use of a dryer, and washing their jeans much less frequently. The LCA also led the company to start other initiatives in sustainable design and to reduce land use impacts from cotton. Most importantly, the LCA allowed them to best prioritize their time and effort toward the biggest impacts. Another benefit to conducting an LCA is that you can start to plan for your impact reductions proactively instead of waiting for your sector or a certain ingredient that you depend on or an impact to be regulated. Usually, if you wait for regulation, it will be more costly and cumbersome to react to it. We started performing LCAs on our products in 2012, and we've covered each of our product families. Because our products use a lot of energy and are used in the industrial manufacturing sector, their impacts are greatest in the use phase of their lives. So it is their use, when they are with you, our customers, throughout their useful lives, that creates the biggest environmental impact by far. And this is true across all impact categories that we measured: human health, ecosystems, water, energy, and carbon. Our first and second place impacts in the use phase are bigger than all of our Scope 1, Scope 2, and some Scope 3 emissions combined. So that means that first and second place are bigger than heat, fleet, refrigerants, purchased electricity for our manufacturing and office facilities, all of our inbound and outbound logistics, business travel, and commuting combined. So obviously we can't ignore these top two impacts. The number two impact of our products is the energy that they're used to cut your material. Now, that's not surprising, because if you cut with our plasma, you're creating temperatures as hot as the surface of the sun. And if you're using water jet, you might be using 60,000 PSI pressure that can cut through anything but diamonds. So of course, that is going to take a lot of energy. Our engineers continue to work to make all of our products as energy efficient as possible. We also work on enabling quality cuts, so there's no need to rerun the cutting process. And we'll continue to innovate around using the lowest amount of energy we can to enable that high quality cutting. From there, the type of energy that our products use is in your hands, as well as in the hands of your utility providers. If you can use renewable energy directly on site is best, or through the purchase of guarantees of origin or renewable energy credits, certificates, or power purchase agreements, this will reduce the impact of that energy use. But that leaves the number one cradle-to-grave environmental impact of Hypertherm's product. And it's part of the cutting process that happens with you, our customers, so I'm curious to see if any of you can guess what that is. So put some guesses into the chat as to what Hypertherm's number one product impact is. I'll see if someone can guess it. Not yet. I see somebody did guess it. The answer is scrap. So the picture you're about to see shows a beautiful nest of parts being cut, and it looks to be relatively efficiently done. But that scrap that remains is pure waste, and you lean practitioners out there know that we need to always relentlessly pursue waste. It's fitting that what remains after the parts are cut out is called a skeleton, because it really does represent the death of value. When we see this scrap every day, it starts to just feel normal, and it's inevitable, and we've become probably a little bit too complacent about it. We recently looked at data from millions of customer cutting jobs over several years and found that 42% of nests achieve under 70% utilization. Unfortunately, that was worse than I expected. So let's take a step back and envision the basic components of your cutting and shaping processes. First, you have your inputs, your raw materials. You rely on them, and they're getting more expensive every day. Next is what I call the black box of your process. You can close your eyes and imagine your process. Part of it might be Hypertherm and Omax products, additional equipment, but it also includes your ingenuity, your designs, your processes, and your people, machine operators, maintenance, material handlers, engineers. It's your revenue-generating machine. It's your value creation magic. So yes, your black box creates value. Your raw materials, then your magic process, and you make parts and products with a much higher value than the raw material and labor that you put into it. That's how you're profitable. But alongside those parts is the waste, the scrap, and even if you get paid for it, you are destroying value. Scrap is also destructive to the environment as well. So many resources, so much energy is embodied in that material, and yet it's now viewed as useless. So I have an example of how your revenue could be impacted by increasing utilization on a process like this. Now you can write these numbers down if you want, because they're pretty startling. If you cut 1 million pounds of raw materials per year at 70% utilization, and you can increase that utilization by just 5%, your earnings could increase by 40%. And if you make that same 5% improvement in utilization, but you're starting off even worse at 60%, you gain even more, an earnings increase of 43%. Another customer's data showed a 6% earnings increase with a 1% utilization increase, and a 22% earnings increase with a 4% utilization improvement. This type of relationship is called a logarithmic curve. This means that there are steep improvements in the beginning, and then the improvements level out. So those small initial improvements in utilization drive big improvements in expense reduction, which means don't hesitate to put in a big effort to gain a few percentage points in utilization. To put this more succinctly, if you want to reduce your environmental impact, increase your raw material utilization any way you can, including using ProNest software to its fullest. ProNest has modules that can help you nest across jobs, use remnants, and run different algorithms that will improve your utilization. We've already learned that customers can get stuck in a rut, using only the modules or algorithms that they always use, and they're actually missing out on improving their utilization and their costs by those precious few percentage points. Given that some waste will in fact be inevitable, there's also the possibility of using waste as is instead of recycling. Is there a use for your scrap skeleton as a product for someone else? This would be very complicated and would require partnerships across industries, sharing of data and information, and perhaps even require material brokers to match supply with buyers. Certainly a challenge, but it would make a big difference. Now, we've just dug deeply into your raw materials and the value that you can create or destroy. We all know that we live in a resource-constrained world, a world of finite resources, so we always have to think about using fewer resources to get our work done. You might have heard of Amory Lovins. He's an American expert on sustainability and energy efficiency, and one of his sayings is just my favorite. It is, "Cold beverages and hot showers are all that people really care about." What he means is that when we want a cold beverage, we don't really care about how it got cold. We don't say, "I want a compressor and a fan and expansion valves and an insulated box that uses electricity," right? We don't want the refrigerator per se. We just want what it delivers, which is a cold beverage. So if that can be delivered using fewer resources, the planet wins, and you probably win too with a lower cost cold beverage. Using fewer resources to deliver our products is key for all of us to exist as a business. The businesses that survive are going to be those that depend on and use the fewest resources going forward. Efficiency is really key to business continuity, both on the short and long term. So this leads me to the concept of circularity. Circularity is the concept that all resources should be kept in circulation, that products should be designed with that in mind, and economic growth should be decoupled from the consumption of finite resources. The most impactful circular solutions involve refusing to use a product at all, and the best example I can think of is refusing to travel for a business need if the need can be met by having a video call. We could probably all innovate around training, maintenance, technical service, even sales, and how these could be delivered without flying a team of people across the globe. The inner loop you see on this diagram from the Ellen MacArthur Foundation is share. This is an example of rethinking your product. Using products more intensely can also reduce resource use. For example, sharing a piece of equipment, a car, or using a service instead of a product, such as hiring a person to mow all the lawns in your neighborhood instead of everyone owning a lawnmower that's only used once a week. From there, we move outward on the diagram to maintaining and prolonging the life of our products, reusing them, or partnering with a supplier or vendor, or remanufacturing or refurbishing ourselves. Scrapping a product by recycling it should be the last choice, and landfilling or incinerating should not be considered at all. Because when that happens, those resources are lost forever. Water use is another challenge that can definitely be improved by applying those principles of circularity. If you're using water jet cutting processes, you have the opportunity to use less water in the first place by working with experts at Omax and Hypertherm to optimize your cutting process while using the lowest flow of water possible. You also have the ability to reuse, filter, and cool your water in a closed loop, drastically reducing your use of what could become a scarce resource over the course of just a couple of months. And know that it's not just scarcity of water that can be a problem. Too much water in the natural environment, such as during a flood or high water table, can also mean that your municipality, your infrastructure, or even the natural areas around you could become incapable of accepting the water that you want to output, and you may no longer be able or allowed to discharge it. Approaching your product and your business strategy through the lens of circularity can help you innovate, improve, and reach new markets. Think of this. If no one had innovated around certified pre-owned cars and only new cars were available, there would be a huge number of people who would not be car customers at all. Looking at this diagram, I want you to see if you can think of one area as a personal consumer where you've purchased something that is used or refurbished, or participated in a sharing ownership model, and put that into the chat. All right, thank you for that input. Let's see if there's any more. All right, some good examples there. I'm seeing Uber. That's a great example of increasing the utilization of a car instead of having so many cars with very low utilization and parked most of the time. Now, looking at the diagram again, think of a way that you could use one of these circular strategies for your business, either as a purchaser or for the products that you sell, and put those in the chat. All right, business uses or business applications of circularity. I'm seeing the ideas of leasing equipment, either on the purchase side or the selling side. And I'm also seeing participating in those secondary markets, just as the used car manufacturers do. In conclusion, I want to acknowledge that as manufacturers, you have immense power to make a change. You have this power now, so seize this opportunity to make a difference because you're in a position privileged to be able to do so. Here are my parting tips. Number one, don't wait until energy prices are higher or until resources are more scarce. Energy prices will go up and resources will get more scarce. So implement the energy and material efficiency initiatives now and start getting the benefits now. Number two, specifically don't wait until water is scarce because water scarcity can happen quickly and it will threaten your business continuity. Depending on where you are, water might be a low cost for you right now, but once it becomes scarce or unavailable, it will go from cheap to infinitely expensive overnight. Take measures now to design processes, and that's just not cutting processes, but all of your processes to reuse and recycle water to reduce those risks. Number three, unleash your creative powers on solving your sustainability problems. Your innovation processes will be strengthened for use on other challenges later by flexing them for sustainability now. Number four, partnership is required to solve these enormous challenges. You can definitely start by making changes that you have complete control over and implement those changes now. But when you're done with those, to make real and lasting change, you'll need to partner with your customers, your suppliers, your competitors, researchers, and others. Partnership could mean collaborating on a project, and it could also mean sharing your data, your knowledge, and your experiences to help others learn. Lastly, I'd like you to all hear from each other. So please enter some words into the platform for the word cloud to answer this question. What is the next green challenge that you are excited to take on? I see zero landfill. That's a good one. And internal carbon pricing. Yes, that is a great mechanism for driving change and really bringing those dollars and cents to bear on your processes. At Hypertherm Associates, we take our own sustainability journey very seriously. It is one of our core values, and it's built into every product and service. Thank you so much for your participation and your enthusiasm. Best wishes to you on your sustainability journey, and please reach out to us with any questions. I hope I'll see you again in either my breakout session called Greener Cuts or a roundtable discussion later in the program.
Thanks, Robin. We hope you found this session enlightening and valuable. To make the most of your time, please prepare yourself for our next session. Let's talk Omax Waterjet, from concept to creation, that will get presented by Arian.
Thank you, Tim. Hello, and thank you for joining me today to discuss Omax Waterjet Systems. My name is Arian Vandergaan. I am the Product Marketing Manager for Hypertherm Associates Waterjet Division, including Omax Waterjet Systems. During today's session, I will be walking you through the process of designing, programming, and cutting a series of parts on our Optimax 60X system with the VersaJet 5-axis cutting head. Throughout the process, I will highlight key features and benefits that streamline and maximize productivity, in addition to optimizing the cutting outcome. The inspiration for this group of parts was based on a common corner joining method in woodworking, the dovetail joint. I wanted to create a box that would remain intact without any fasteners or welds. The dovetail joint consists of a tail and socket, and when connected, interlocks the two pieces together. To begin, I designed each of the sides of the box in SolidWorks. The overall box size was approximately 6 inches wide by 9 inches long by 5 inches tall. I selected 3/8-inch aluminum for the design to keep the weight down on the finished assembly and reduce the overall cutting time while still demonstrating the features and capabilities of the abrasive waterjet system. The dovetail joints were approximately 2 inches long at the base with 60-degree angles on the sides. The short sides included a single dovetail, while the longer sides included 2 dovetails to increase rigidity. For the top, I also added a small through hole to attach a handle when the box was complete. To make all the sides and top remain in place without fasteners or welds, I designed the dovetail joints to require assembly in a specific order. First, the bottom of the box was designed with sockets on all sides so that the sides had tails to slide into the joints. This would ensure the bottom remained attached when the box was picked up. Second, the long sides were designed to have tails on the bottom and sockets on the sides and top. The long sides needed to be installed on the bottom prior to the short sides. The short sides were designed to have tails on the bottom and sides and sockets on the top so that the short sides would keep the long sides in place. The short sides must be installed after the long sides and prior to the top. Finally, the top was designed with tails on all 4 sides. These tails, when interlocked, retained the parts, preventing them from separating from the bottom or sides. Once the top was installed, the box would remain intact. I utilized the Hypertherm Associates logo on the short sides and the Omax Maxit logo on the long sides, both imported into SolidWorks in DXF format to create the reliefs on each of the sides for added interest. I chose to design the parts in SolidWorks to allow previewing the parts in a 3D environment. While the parts could have been drawn in a 2D CAD program, designing in 3D enables error checking form and fit. Once all parts were designed, I created an assembly of the parts using mates to join the dovetail joints in the correct order and orientation. After the model was fully designed, I was able to check the assembly to ensure that the angles and other dimensions of the parts and dovetail joints were correct. This extra step in the design process ensured that the parts were designed correctly prior to programming the cut. As you can see here on the screen, the final assembly form worked correctly, and I was ready to proceed to the next step. I next used Omax IntelliCam software to create the cutting path, including tilt commands of the sockets for the sockets of the dovetail joints. Omax IntelliCam software is a standalone software program that can be used to create 3D paths, rotary paths for use with systems set up with a rotary axis, as well as converting 3D parts to 2D cutting paths, either by selecting a face of the 3D part as the cut profile, or by slicing the 3D part to cut a cross-section of the part. This can be very useful for cutting a gasket for a solid assembly. Each of the sides, top, and bottom SOLIDWORKS parts were opened in IntelliCam. I then used the 3D Pather tab and the AutoPath tool to create the cut and traverse paths. The part paths were then saved as DXF files for importing into OMAX IntelliMax software. Saving the parts as DXF files from IntelliCam embeds the appropriate traverse lines, lead-in, lead-out lines, and cut lines, including tilt information, to be used by the OMAX IntelliMax software. So after creating the individual DXF files with all the associated bevel information using IntelliCam, I then opened OMAX Layout. Layout is one of several programs within the OMAX IntelliMax software suite. This program can be used like a 2D CAD program to design parts, as well as be used to create nests of parts. Once all parts are nested and the traverse and cut paths are established, Layout can be used to generate OMAX machining files for use on OMAX WaterJet systems. I first opened the short side DXF file to load it in Layout. I next used the insert function to add the remaining DXF files for the box. This included 2 short side parts, 2 long side parts, 1 top, and 1 bottom. Once all 6 parts were loaded, I moved the parts to optimize the plate size I planned on using for the cut. Moving parts or portions of a part or drawing is easy within Layout. Simply select the entities you want to move, click the Move command, and click the starting point and ending point for the entities. You can use snap tools to assist aligning the entities or parts. After the parts were arranged according to the desired configuration, I removed the existing traverse lines to the first lead-in on each part. This was important because the DXF files were individual part files and had traverse lines applied as if each part were to be cut separately. I then used the Line tool to create new traverse lines from the start of the nest to the finish point. I created traverse lines to connect the lead-out line on the external profile of each part to the first lead-in line on the next part of the nest. I then changed 2 of the traverse lines to be heads-up traverse lines. What this means is the cutting head will retract a set distance, configurable in the machine settings, prior to traversing. This is very useful when traversing over a completed profile in the event the part has tipped up. Where possible, traversing without first retracting is preferred to shorten the overall path time. Once the parts were nested with connecting traverse lines, I used the Post tool to generate the machining path. The Post tool first prompts the user to select the starting point of the cut. The software then automatically calculates the cut path, including tool offset and cutting direction based on several parameters. The calculated tool path is displayed within a preview for review. If the path looks correct without errors, you can simply select Save to create the OMX file for the machine. After creating and saving the OMX file, I opened OMAX Make software. Make is another program within IntelliMax software suite and is the software used by the OMAX WaterJet system to control the motion and cutting parameters. This software can be used on a personal computer to preview the cut path and estimate machining parameters, including amount of abrasive required, total cut time, and the length of the cut, among many others. I first clicked on Change Path Setup to load the nested parts and enter material type, thickness, appropriate tool offset, and other parameters in the setup. Once the cut path was compiled, I reviewed the compiler messages for any warnings or errors. The compiler will detect potential issues with machine motion, such as part entities that cannot be cut due to mechanical restrictions of the setup. In the case of this set of nested parts, there were several warnings regarding the orientation of the rotational axis of the VersaJet head. Because these were warnings and not errors, I was able to proceed with previewing the cut path. The cut path can be viewed in both 2D and 3D views. I used the 3D view of the machine to see the VersaJet cutting head tilt and rotation movements and check for any potential collisions or issues with the cut path. The 3D table view is a new feature released with IntelliMax version 33 software, which comes with all Optimax WaterJet systems. The 3D view allows users to see the potential cut path and machine motion prior to cutting on the machine, as well as real time during the machining process, which you'll see a little bit later. This view can be rotated, which allows users to see the cut path from different angles and see the jet stream below the material. This allows users to detect potential areas the stream that could contact the sides of the machine or any potential material clamps or other structures in the tank. All machine motion, including heads-up traverses, tilting, rotating, and XY motion, can be previewed prior to cutting on the machine. Views can be configured to show the entire machine, the head, the nozzle, or just the nozzle by itself. The machine and slats can also appear as a hologram to allow easier viewing of the material and cut path. Standoff and other information can be configured to appear depending on zoom level. Cut statistics, including time for the path, estimated cost, estimated abrasive needed, are also still visible in the 3D view. These values are based on the input parameters and will be recalculated each time the parameters are changed or updated. So that brings us to our first poll. The material, and I apologize, these are all in imperial measurements, but the material selected for this cut was 3/8 inch aluminum 6061. The machine was set up with a 14 thousandths inch jewel diameter and a 42 thousandths inch mixing tube diameter. The pump pressure was set at 60,000 psi and 3/4 of a pound per minute of abrasive flow. This was using 80 mesh abrasive. So, based on the material type, thickness, and operating parameters, what is your best guess at the total cut time for this nest? Is it A, approximately half an hour, B, approximately 1 hour, or C, approximately 1.5 hours? We have quite a few answers coming in, with the majority selecting A for the results. The actual answer, the correct answer, is B. The actual time for this nest is approximately 1 hour and 8.5 minutes. So now that the parts were nested, or were designed, nested, and previewed, it was time to hand things over to my colleague Kai. Kai is the team leader for our Advanced Technology Center in Kent, Washington. He utilized our Optimax 60X cutting system in our training lab to complete the cut. The first step in the process is to ensure the table is homed correctly. After loading the nest, Kai clicked on the notification indicating the machine needed homing and selected Begin Homing to complete the homing process. A new homing routine has been introduced with the launch of the Optimax cutting system. This new system eliminates the need to home the machine against a hard stop, significantly improving homing speeds and enabling automated, accurate bridge squaring. Once the machine was homed, Kai set the height of the cutting head for the nest. Proper standoff is critical when cutting with a 5-axis head. Now, while users can utilize a terrain follower to set and adjust the nozzle standoff during a cut, for this demonstration, we chose to show the manual process of setting the cut height. The target standoff for the VersaJet cutting head is 80 thousandths of an inch. Kai positioned the nozzle at different points around the plate and utilized a standoff tool to measure the distance from the nozzle tip to the material. Material thickness can vary with some materials, and setting the standoff to the highest point on the material is critical to prevent the nozzle from colliding with the material during the cut. Using a terrain follower will automatically adjust for material height variations, eliminating the need for this step. Kai next raised the cutting head to attach a nozzle splash guard to reduce the amount of nozzle spray, particularly during piercing, when the jet crosses a support slat during the cut. Next, after lowering the jet back down, the water level was raised so that the nozzle was submerged by approximately 1 inch of water. Underwater cutting has many benefits, including reducing garnet and water splash, minimizing frosting on finished parts, and lowering noise level to approximately 76-75 decibels. The Optimax Rapid Water Level Control System is an easy-to-use in-tank pneumatic system that enables you to quickly raise and lower the water level of your catcher tank for underwater cutting. System control is located on the mobile controller for easy access. The final step in setup prior to starting the cut was to home the tilt axes to ensure proper angles are achieved during the cut. That brings us to our second poll. Based on the parameters presented previously, what is your best guess at the total cut length for this nest? So when referring to cut length, this does not mean include the machine traverses between the parts. Is it A, approximately 9 meters, B, approximately 10 meters, or C, approximately 11 meters? See results coming in with the majority selecting 10 meters. So in this case, the correct answer with the fewest votes is A. The actual cutting length is approximately 365 inches, or about 9.25 meters. Now, the total length of the tool path, which includes traverses, is about 461 inches, or 11.7 meters. At this point, the nest is loaded, the plate and machine are set up, and the cut can begin. Now, because the cut time is slightly over an hour, as we found out in the first poll, the video speed has been increased between 3 and 4 times the actual cutting speed. While the machine continues to cut in the background, I'd like to take some time to provide an overview of the features and benefits of the Optimax abrasive water jet system. The Optimax system is the culmination of over 3 decades of engineering expertise and experience. There are many aspects of the system that provide significant benefits to owners and operators, including advancements in the drive system, the high-pressure pump, IntelliMax software suite, and the cutting heads. Continuing with the wide success of the IntelliTrax drive system in our Omax and Maxium product lines, the Optimax product line incorporates the patented drive system for both X and Y rails. The IntelliTrax drive system, designed specifically for abrasive water jets, consists of 3 key elements. First, the IntelliTrax drive mechanism moves the carriage along a rail, providing excellent control of velocity and acceleration without excessive vibration. Second, a precision linear encoder provides a locating resolution of 1 micron to accurately determine location. Third, an electronic feedback feed-forward system links the IntelliTrax drive mechanism and the linear encoder to provide extremely accurate positioning and, if necessary, allows automatic adjustment of future commands to compensate for discrepancies between commanded and actual positioning. The mounting and engagement method for each drive on the X-rails has also been improved to allow rapid installation and easy access for service. As mentioned previously, a new magnetic marker along the middle of the linear encoder tape on both X-rails and Y-rail removed the need to home the machine against a hard stop. This improved homing routine speeds up the homing process and enables automated, accurate bridge squaring. The software and hardware improvements, as well as the addition of the IntelliTrax drive for the Y-rail, builds upon the Omax and Maxium product lines to deliver the most reliable and robust motion control system in the industry, ensuring customer peace of mind that cutting performance on day 1 will match cutting performance on day 1001. The new mobile operator station for the Optimax product line enables the operator to move the controller for ease of path setup or viewing the cutting process. The ergonomically friendly design includes an adjustable monitor and a durable work surface, as well as a storage drawer for storing nozzle consumables and other small items you may need. New for the Omax product collection, a redesigned mini hopper incorporates several design enhancements and processes to improve ease of use and system robustness. First, a fluid diverter at the bottom of the mini hopper directs water away from the hopper, ensuring abrasive in the mini hopper remains dry when a nozzle clog directs water up the abrasive feed line. Second, if a nozzle clog does occur, which happens, an automated process within IntelliMax software called Air Sweep purges the nozzle and abrasive feed line with air and water to remove the clog. This automated process eliminates the need to disassemble the nozzle and the mini hopper, significantly improving the user experience during operation. Multiple improvements and advancements have also been made with the high-pressure pump. Available in sizes from 30 all the way to 50 horsepower, the next generation of EnduroMax direct drive pump incorporates several key features to optimize pump operation and reduce dependency on skilled labor. The new maintenance-friendly pump design includes thermal-formed covers, which significantly reduce weight, making them easier to remove and install. The removable top cover for the new EnduroMax pump also allows access from all sides of the pump. Key changes to the frame structure, such as the removal of the crossbar and maintenance item placement at the front and top of the pump, ensures easy access and quick replacement of service parts for fast return to cutting. New to the EnduroMax pump line, the motorized adjustable dump orifice, or MADO, is automatically monitored through a pressure feedback loop and adjusted to ensure actual pressure matches commanded pressure. This minimizes dependency on the operator to manually adjust and manually monitor, and is particularly valuable when changing orifice sizes. The next generation of EnduroMax direct drive pumps automatically sets the correct pressure based on values you enter in IntelliMax Make software during that setup process we saw earlier. This automatic pressure setting and monitoring minimizes pressure fluctuations to improve component life, extends maintenance intervals, and delivers expected cutting outcomes. A new single-piece crankcase has been integrated into the new EnduroMax pump line. The improved plunger alignment provided by this single-piece design enables up to 1,000 hours of cutting time between maintenance intervals. In addition, the design incorporates an opening for easy viewing of and access to plungers for maintenance. The EnduroMax charge pump is automatically started by the control system when process water temperature is out of range, and it's stopped when pump is off and process water temperature falls back within range. This water-saving feature ensures optimal process water is supplied to the pump and further reduces dependency on the operator. IntelliMax's next generation of premium software, developed specifically for water jet cutting, is designed for ease of use, enabling operation within minutes of installation. The new IntelliVisor console provides extensive system monitoring and feedback to guide operators, minimizing the need for skilled operators and helping to optimize operations. Event logs notify operators of alerts and faults for ease of troubleshooting. In addition, real-time monitoring of temperature, pressure, system utilization, and other system data provides important information about the status of the cutting system. The cutting system takes action to address an out-of-range value, or notifies the operator of the potential need for action. Maintenance item and event tracking in hours or cycles enables proactive maintenance planning. System information is visible within the System Status tab in Make. Also, the IntelliVisor console can be viewed separately from the Make interface to view more detailed information. The IntelliMax software suite, designed to run on Windows 10 64-bit operating systems, builds upon the current generation of market-leading IntelliMax software and introduces new, improved user interfaces for Make and Layout with intuitive, redesigned functional icons, making it even easier to rapidly learn and use the software. Adding extra data, or X-data, to features such as machine pauses or delays is easy to learn through enhancements that guide the user through application of X-data elements. Optimax cutting systems are available with 3 different cutting head configurations, from standard 3-axis to full 5-axis cutting capability with taper compensation, like shown on the Optimax today. As customer production requirements and demands change, the universal upgradability of the Optimax system allows customers to easily upgrade from a programmable Z-axis to a Tilt-A-Jet taper compensation head or a VersaJet 5-axis cutting head. Key in this factor, all three configurations incorporate identical focal points, enabling rapid return to service following installation. The VersaJet cutting head, shown on the Optimax 60X today, is a completely software-controlled, multi-axis cutting head that greatly expands the versatility of the Optimax cutting system. With a cutting range from 0 degrees to 60 degrees, the VersaJet can easily cut beveled edges, angled sides, and countersinks, as well as complex 3D shapes. With its inherent high level of positioning accuracy, the VersaJet can cut parts that require no secondary finishing, significantly reducing part production time. In addition, the VersaJet head is capable of fully automatic taper compensation to virtually eliminate taper on finished parts. Building upon the success of the A-Jet 5-axis cutting head offered on the OMAX and Maxium cutting systems, the VersaJet cutting head provides improved serviceability, increased robustness, including improved sealing against moisture, and field replaceable shear screws. These changes ensure customers experience maximum uptime. Industry-leading design and performance incorporated into the Tilt-A-Jet cutting head represents OMAX innovation in the continuing search for more accurate abrasive water jet machining. The Tilt-A-Jet cutting head can position the nozzle at any angle calculated by the software to exactly offset the taper from the jet. Taper doesn't disappear, it's just moved to the scrap part of the material, leaving your part with near perfect square edges. The Tilt-A-Jet cutting head features automatic re-squaring as well to ensure the nozzle is square to the table. Enabling tilt forward allows faster cutting by directing the jet stream forward into the path of travel, optimizing the jet's power for the cut. Fully automated taper compensation calculations ensure optimal throughput while reducing dependency on skilled operators. In addition to the above system enhancements, many new accessories have been added to improve the user experience, including the workpiece lighting kit visible on the Optimax system in this video, as well as a machine status indicator on the bridge to indicate operational status of the machine. The optional machine status indicator provides system status information at a glance. Visible from a distance, the 4 status colors white, green, amber, and red alert users to current machine status. A white light indicates that the machine is idle, but is ready for operation with no faults or abnormal conditions. Green represents normal operation, indicating a water jet action is taking place, such as performing a cut, move, or test, and no faults or abnormal conditions are present. An amber light indicates an abnormal condition, but the water jet can continue performing cutting and moving operations. A red light indicates a fault condition, and the water jet will be unable to perform any cutting operations until the situation is addressed. The optional workpiece lighting kit incorporates 2 LED light banks on the underside of the bridge to illuminate the workpiece. This feature greatly enhances the ability of the operator to clearly see nozzle location, and as you saw earlier when Kai was setting up the system, aids in cut setup. The LED light banks will turn on when power is applied to the table enclosure. These are many of the features and enhancements that have been incorporated into the Optimax cutting system. These enhancements and more combine to make the Optimax the most reliable and robust cutting system in the industry. As the cutting process is nearing completion, let's shift our focus back to the final moments of the cut. Now that the cutting has completed, it's time for our third and final poll. Again, remembering the parameters based on those parameters presented at the start of the cut, what is your best guess at the total amount of abrasive used for this nest? Is it A, approximately 18 kilograms, B, approximately 22 kilograms, or C, approximately 28 kilograms? It looks like quite a few answers are coming in at A, followed by B, and C are kind of tied with 22 and 26 kilograms. All right, the correct answer is B. The estimated amount of abrasive used is about 47¾ pounds of abrasive, or about 21.66 kilograms. So now that all the cutting is done, the final step in this process is to assemble the parts and see if we were successful. As you can see here on the video that's showing all of the parts laid out, and as we start to assemble the parts, we can see that they were all cut successfully, and when assembled, the final box will remain intact. Thank you very much for taking the time to learn about Omax WaterJet systems. I'm always happy to answer any questions, and feel free to reach out at any time. Thank you, and have a great rest of your day.
Thank you, Arian, for this interactive and engaging session showing how you can easily transform from concept to creation. I am sure this session showcased how easy users can design, program, and cut parts without the need for the secondary processing. Now, let's dive into the breakout program for today.
You can choose from one of the following topics. Learn how ProNest CAD/CAM software can maximize parts per plate and support your sustainability goals at the same time. This session will be available in English. Another breakout session on WaterJet cutting, versatility, and Omex IntelliMax will explore its wide applications, unique capabilities, and optimal intensifier pump scenarios. See the benefits of cutting with WaterJet: reliability, ease of use, increased efficiency, and lower operator dependency. Select the available selection language that works best for you: German, Finnish, Italian, Polish, Romanian, French, and English.
Take a moment to check out our sessions. Each session typically lasts about 40 minutes, and you won't miss a thing, as we'll automatically return to the main stage at 4:10 Central European Summer Time for our engaging roundtable discussion. It will be a great opportunity to interact with industry experts and get answers to the questions you wanted answered most. Nothing to worry about, just stay connected. Once the breakout room module shows, join the session that interests you most and feel free to switch between them as needed. Plus, remember that all sessions are recorded for your convenience. But before we dive into the breakout sessions, we've scheduled a short break to allow you to choose your preferred session and refresh. The breakout sessions begin at 3:30, and our roundtable discussion kicks off at 4:10. So, stay with us for an enriching experience.
Good morning, good afternoon, and good evening. We hope you're enjoying the virtual event so far. Welcome to Shop Talk Live and to this breakout session. Let's talk shaping the future of manufacturing. It's great to see so many of you joining us from all over the world. We're excited to share valuable insights with you over the next 40 minutes or so. I'm Robin Tyndall, and Robin Henschel and I will be the speakers for this breakout session. Before we dive into the content today, I wanted to remind you that the breakout session is designed to be interactive, engaging, and most importantly, informative. The best sessions are those where your questions get answered and your concerns are addressed. So we encourage you to participate actively throughout the session. And we have multiple ways to ensure your questions get answered. Some of you submitted insightful questions during the registration, which helped shape today's content, so thank you for doing that. And in addition, please ask questions throughout the chat by using the chat feature on the breakout session. Our dedicated team of assistants will monitor that chat, and our goal is to cover as many queries as possible, though if we don't get to all of them, rest assured that we will follow up afterwards. Again, a warm welcome to Let's Talk, Shaping the Future of Manufacturing. Get ready to engage and make this session informative and interactive for everyone. So in our visits and conversations with customers, both Robin and I have heard that they're interested in being more sustainable and more profitable. Maybe this sounds like you. Maybe you're doing well in one of these categories, but not the other. Or maybe you're doing great. Maybe you're already sustainable and already profitable, but you'd still like to do better in both. Well, the good news is that your challenge is our challenge. We have a triple bottom line mission, and we consider it part of that mission to enrich our communities and the environment. And we consider it a critical success factor that we reduce the environmental impact of everything we do. And everything we do includes you, our customers. So we've assessed the life cycle impacts of our products, and it turns out that the #1 impact is the scrap that's created during our customers' cutting processes. And the #2 impact, but it's a distant second place, is the energy that you, our customers, use while cutting. So yes, that's correct. The environmental impacts of scrap created when you cut your raw materials is a bigger impact to the environment than all of Hypertherm's logistics, operations, energy use, and travel. So scrap costs you a lot of money. We recognize that, and I'll touch on that in a moment, but it costs the environment a lot too. And that's really all about the life cycle impacts of the material. Whether it's metal or something else, there is embodied carbon. And that's because of all the processes that it takes to mine, manufacture, and transport that material. So even though we assume that it's 100% recycled at the end of its life when it is scrap, which is quite easy to do when it's metal, it is still the biggest driver of environmental impact. So, as I just mentioned, that second place impact is energy use, and that's part of our shared challenge, certainly. I'm pretty sure that you all understand this really well already because you've been paying your energy bills every month. So right now I'm going to focus on explaining why scrap is such an amazing improvement opportunity. So there's the cost of scrap initially in the form of the raw material when you buy it. So that cost is pretty obvious. But there are also a lot of hidden costs with scrap. Of course, you need labor to move it away. It might cause a time delay in your process. It also might need special equipment, handling equipment or a crane in order to move it. And anytime there's a non-standard process for managing your remnants, there's going to be wasted time. Whether you're storing your remnants really nicely, like this picture on the right, or whether your scrap pile is a little bit more messy, like the picture on the left, the fact is that is costing you overhead. It takes up space, and that space could often be used for something more productive that could generate profits. So that's an opportunity cost. So in our data that we've looked at from millions of nests over thousands of customers, what we've seen is that 42% of nests, which is quite a lot, achieve less than 70% utilization. So we've realized that that's a problem. And to understand why that happens and what we can do about it, I've just drawn this simple diagram. So first you have raw materials and you pay a certain price for those. And what you do with those raw materials is you put them through your process. Some think of it as a black box. Part of that process is your Hypertherm products that you might be using to cut or process that material. But it's also your ingenuity, your designs, your innovations, your process. It's your revenue generating machine. It's like your value creation magic. So yes, your process creates value because you're generating revenue. You're creating much more value than what you put into it. But at the same time, you're in a way destroying value because you're making scrap. Scrap is pure waste. You're taking a raw material that you paid for, you're adding labor that you paid for, and you're getting something worth much, much less, and that is scrap. So really, that's a value destroying process. So let's walk through an example of how you might improve. If you have throughput of 1 million pounds per year of material and you're at 70% utilization, you might have a certain revenue there that we've based on certain assumptions. And if you increase that utilization to 75%, your revenue could increase by 40%. And if you start out even worse at 60% utilization and move to 65, your revenue is going to increase even more. So let's look at another couple of examples here. This example is from a real customer that was a shipyard in the EMEA region, and it was looking at just their annual usage of 12 millimeter thick mild steel. And you can see here what their throughput was in kilograms and what their raw material spend was. And they initiated several projects to increase their utilization by 4%. So they were starting out at 78% and managed to get to 82%. So 4 percentage points increase. So you can see that the weight of scrap that they produced went down, but what they really wanted to see was what that was going to change in terms of their profitability. So you can see there that their profit plus their scrap revenue, and scrap should not be thought of as revenue, from before and after increased by $330,000 or 22%. So the reason that that happens is because from that diagram I showed earlier, where you're either creating value or destroying value and moving in the direction of creating more value through higher utilization, is you're seeing a logarithmic curve. And what that means is for really small gains in the input, you're seeing huge gains in the output, and you're seeing them early. So that's why those small percentage point increases should not be underestimated in terms of the power that they have to increase your profitability. This is just another example where we put in real numbers from a real customer and saw what their earnings increases would be given small increases in their plate utilization. And another way of looking at that is just with a different type of graph where you can see their baseline utilization of 80%. This was under assumptions of 13 millimeter thick mild steel and a 6% profit margin, and how adding 1, 3, or 5% to their utilization could have such a dramatic impact on their profitability. And so I also wanted to just take a moment to explain and put into context what that means from an environmental stewardship standpoint. So I ran this example, again, with 20 millimeter thick mild steel, and running that on a Hypertherm HPR 260 XD heavy industrial system, 2 8-hour shifts a day all year. And what the impacts from an environmental perspective and a carbon perspective would be from doing that is equivalent to 1.5 million miles driven by an average gas-powered car. That's equivalent carbon emissions. And said another way, it's equivalent to burning for power generation 663,000 pounds of coal. So in that first example from the shipyard, if that scrap is reduced by 22%, that's equivalent to avoiding emissions from over 334,000 miles driven. And it's also equivalent to the amount of carbon dioxide equivalent emissions that could be sequestered by 156 acres of forest. So you can see that that's a really big impact. So not only are you rewarding yourself by increasing your profitability, you're doing a good turn to the planet as well. So with that, I'm going to hand the presentation over to Robin Henschel, and he will review some of the techniques you can use to reduce your environmental impacts and increase your profits.
Okay, thank you, Robin. And you showed some really interesting and big numbers there. And I now just hope that I can keep up with these impressive numbers during my presentation. So what can we do from our software, from our ProNest software, with measuring the utilization? So in our ProNest database, we have a bunch of data stored, and among the available data there, we have, of course, information on the blades that we have used to cut all of the jobs in that we have created with ProNest. Among this data is the material length, width, thickness, and all of these. Here we see a short or a screenshot on the export of the data into an Excel file, and you see a lot of numbers in there. And even as I really like numbers, it is hard to get any clue what is going on in there. What am I doing? So what I have seen at a lot of customers that I have visited, they have such a Power BI dashboards, or it's a different software dashboards showing their key figures of their production. And they can easily include these exports from our database into these dashboards to show the utilization. Here we now have an example with the data from my demo system. You see my utilization is not always at the level it should be. This is now all the nests that I have done in the last 24 months. We see the difference in the utilizations, and we can also break this down into different materials. Here now everything on a mild steel 10 millimeter or mild steel 6 millimeter. And of course, when you are measuring your utilization and you want to increase your utilization, you should just see one direction of the graph, and this is going up in the best case up to 100%. Can we always do this? I don't think so, but this is our goal. Before we now dive into the big topic utilization, Robin already mentioned that there is a second topic. This is the energy consumption, which also has an impact on your carbon footprint. And now let's start with this one. First, start with the easy stuff. So when we start thinking about the carbon footprint, we should think about reducing the energy that we are using for the cutting process. And this starts in ProNest right at the beginning when we start to select the cutting class for the job that we would like to do. Of course, it has a big impact on your energy consumption. If you're using a 130M cutting class, a 220 or even a 300M cutting class, the energy consumption will be way different. Of course, when we go for a lower amperage, also our cutting speed will be lower, but also our quality is a bit better. You could now say, okay, but I need the speed because my production is full. I need to cut as fast as possible. Well, even when you go down on your amperage, we have some ways to increase or to decrease the production time of your nests. One of these things that we can use is our collision avoidance module. I know the name sounds a little bit different. The main thing of the collision avoidance module is to avoid collisions of the torch with parts that may tip up during the cutting. To achieve this goal, ProNest is recreating and recalculating every single cutting pass, looking at the torch races and optimizing everything. Due to this optimization, on a simple nest like this one, without the collision avoidance, we have a production time, let's say 1 hour and 33 minutes. And when we now just activate the collision avoidance module in ProNest, then we go down in the production time to 1 hour and let's call it 3 minutes. So it's a reduction of 33% of production time. This is also a saving of energy. And when we can now combine this with a different cutting class, then okay, our saving production time might not be that much, but we are saving the energy on the cutting class. There's also something that we can do in addition to this to reduce the production time. If the quality of the parts allow, we can use the common line cutting when it's possible. When in this nest we now activate the common line cutting function, we see here these parts all now have joined sides. Here it's just a small side, here it's a little bit more. We already see when we now compare this with the original nest that we are using less material for the same amount of parts. But what is the impact, the real impact? Without the common line cutting, as said before, we have a production time of 1 hour and 3 minutes, and we are using let's say 58% of this blade. With the common line cutting, we are now going down to a production time of 59 minutes. So again, 3 minutes saved. And we are just using 54% of the blade. So we have already increased our utilization of this blade by 3%. So we are now coming from the energy savings to the increased utilization on the blade. The common line cutting is just a small tool that we can use to increase the utilization of the blade. And as said, the quality, the cut quality, you must be aware that on the common line cutting you have one good and one bad side. This is the physics of the plasma. Another thing that we can use to increase the blade utilization is the blade saver. The blade saver you can use together with our Hypertherm XPR power source. And with the blade saver, we are utilizing a special lead-in to reduce the lead-in size. Here we have an example of a standard lead-in on, I think this was a 15mm mild steel. This is what you have on the standard settings, the separation between the parts with the standard leads. When we now just activate the blade saver, we see that the dimension or that the size of the skeleton is way smaller. And of course, this is immediately increasing our utilization on the blade. One thing to mention on the blade saver is that this is only available with the XPR power source and on mild steel on a thickness between 12mm and 30mm thickness. If you want to use the blade saver for a nest, how to do it? Well, it's quite easy. When you are selecting the cutting class, just look for a cutting class where the blade saver is in the name of the cutting class, and then all of the settings will be applied automatically. So now let's go to a real example. We have now selected the blade saver cutting class. ProNest has enabled now the special lead that we have for the blade saver. We do here a moving piercing, so we lower the torch while we are doing the piercing. This helps us to stabilize the arc in this short lead. When we now do a nest of these rectangular parts, this is a thickness of 50mm. The blade dimension is 2.4 by 1.2 meters. With the standard cutting class, we have here now 34 parts nested on this single blade. When we look at this one now, we say, yes, it's quite a good nest. There is not much room to add any additional part, right? Well, when we now activate the blade saver cutting class, it looks like this. Same parts, same blade dimensions, but we have 4 additional parts on this blade. Instead of 34 parts, we have now 38 parts. We can compare these two now, and now let's have a look at the utilization. Without the blade saver, we are at 83% of utilization. With the blade saver, we are at 90% of the utilization. So it's a big increase of 7%. Of course, I have to mention that these 7%, you will not get these all of the time. When you are just cutting these kinds of rectangular parts, you will see them. if you are also cutting round parts, for example, the saving will not be that high. And we have measured an average of an increase of 3% on a nest, just depending on the parts that you are cutting. Another thing that I like to mention on the plate saver, as we are doing a moving piercing for the plate saver, we will create a big splash of material during the piercing. Pronest is indicating in which direction this splash is going. And please do not look at the size of this triangle. This is just a symbol. The real splash might be way bigger. In case that you have an operator standing here, you can define in Pronest that there should be no splash to one or to up to 3 sides of the plate. Then Pronest will just direct the splash into the sides that we allow. Okay, so now we do not always have so many parts to fill a whole plate with it. Sometimes we just create a nest like this. And now what should we do with the rest? In Pronest, we can easily create a crop cutting to this plate. And so Pronest will cut off the rest of the plate. We can define in the settings on how this crop cut should look like. Should it just be a straight cut? Should it be a L-shaped cut or a profile cut like we see it here? And also we can define the minimum width and length of a remnant. So in my settings, I said something like this is just too small. I don't want to have this in my stock as I won't be able to use it, but this can be set in the settings. In these remnants that we create here can go into the plate inventory within Pronest. And we can store all of the remnants in there with their actual shape for later usage. So if you are cutting a lot of nests each and every day, and at one point your plate inventory might look like mine here, a lot of remnants in there. And now what remnant is the best to use for the nest that you are cutting at the moment? Well, we have a module called Nesting System Optimization that can help you with this. The Nesting System Optimization module is a quite powerful module, and so we have a bunch of settings that we need to do. Now let's just go quickly over the settings. One of the settings is what nesting strategies should be tried for during the run of the module. Should this module just look for one plate size for all of the nests in this job, or should it always look for the best plate for each and every nest within this job? And now one of the interesting things is we can also say to this module that it should include the material costs into its calculations. So we can say a remnant from our side is always cheaper to use as a new plate, as we want to have a turnover in our stock, and we don't want to necessarily use a new plate. We want first to use our remnants that we have on stock. As Robin said before, there's nothing more expensive as having remnants on stock that are not used. This scrap that is just laying around. When we have done all of these settings, Pronest will start with running through all of the possible plates with all of the strategies that we have selected. We see here a total of 125 trials are done. At the moment, it is here at trial number 3, and the best utilization found is at 45%. A little bit later in the process, we are at 72.5%, and this will now go until it has done each and every trial, and in the end it will come up with the solution. This remnant now here was the best choice for these parts that needed to be nested. So this module is a great way to use your remnants that you have on stock, but wouldn't it be better if we would not have any remnant? We would save the energy for the crop cutting and the remnant handling. Okay, maybe these savings are not more as a water drop on a hot stone, but when we think about it, even the Grand Canyon just exists because of a single water drop which started the process. So let's think about what could we do to not even create a remnant. We have a module called Production Manager. This shows you a lot of data on all of the nests that you have already cut. So for example, if it's in production at the moment, is it pending, or is it already a finished cut? It also gives you information on the material that is used, on the plate side, and on the available free space on this plate. If we now have, for example, some parts that we need to nest on a mild steel 10 millimeter, we can type this into the search bar of this nest view in the Production Manager, and the Production Manager will show us all available nests for a mild steel with 10 millimeters. We now can have a look at the utilization or at the available space on the plate. We see here we now have 60% of space available. We can have a look on how this nest looks like. We say, yes, I want to add my parts to this nest. I go into the nest. I look up which ProNest job this one is. I remove the output from the plates to cut so that no operator can now cut this job while I am modifying it. I go now to ProNest, modify my job, and now my PowerPoint didn't want to move to next slide. And now we have modified everything, and we see in the end, when we look again, free space 3%, 1%, 1%. And so we have saved now a lot of utilization or a lot of plates in our production without even creating a remnant anymore. If the 1% is really realistic to achieve on each and every nest, I don't think so, but we need high goals. Okay, so this is now the part from my ProNest software, and now I hand it over to Robin again for a quick summary.
Great, thanks, Robin. So in conclusion, I hope that you've learned from this session that you have immense power. So first of all, you have the power to understand that scrap is not revenue. It's value destroying, and it also impacts the environment. But you have the power of your Hypertherm products, and specifically ProNest. You have the power to make the change to be more sustainable and more profitable than you are today. So I'm going to hand it back to Robin now to go through some of the Q&A that has come through.
Okay, thank you, Robin. So we have now finished the main part of our presentations. Now let us go to our Q&A part here. We have been receiving some questions during the registration process. We will now handle these questions. All other questions should already have been answered in the chat by our colleagues. If there are still some pending questions, we will come back to you with the answer a little bit later. Okay, so the first question, it's one for me. Can ProNest work with other cutting processes as plasma? Yes. We know that Hypertherm is mainly known for plasma cutting, but our ProNest software is not just solely for plasma cutting. We can also do oxyfuel cutting. We can do plasma cutting. We can do water jet cutting. We can do laser cutting. It's all not a big deal for us. We also have done some knife cutting already and other things. So yes, definitely, we can do other cutting processes as just plasma. For a more detailed answer, please just send an email to one of us. We will go through how you can contact us a little bit later. Okay, second question, again for me, that's nice. Can Pronest work with non-hypertherm equipment? Yes, of course. And my colleagues sometimes hate me for this when I say, for me, it does not matter if this is a hypertherm power source or if this is a laser from some competitor. With Pronest, we are not bound to the hypertherm equipment. We can work with any CNC controller. We can work with any plasma power source, with any laser. The only requirement that we have when it comes to CNC controllers is that they accept a human readable code. There are some controllers out there, especially they are coming a lot of times from China. They accept just a binary file. And we cannot reproduce these binary files because we do not know what is in there. But also for these days, a workaround, most of them accept a DXF file. So we do the nesting in Pronest, output the whole nest as a DXF file, and then hand it over to these controllers. Okay, and I think the last question, this one is for you, Robin.
Yes, you're right. So someone asked, as a customer, is that scrap that is created by you, the customer, during your cutting process, is that considered a scope 1, 2, or 3 in terms of its carbon emissions? So the answer is, for you, the customer, that is considered scope 3. It's also considered part of Hypertherm's scope 3 carbon emissions. So in that way, we're kind of jointly responsible for that. In terms of the energy use, that second place environmental impact, the energy that you use when you go through any cutting process in your factory, that is considered a scope 2 carbon emission for you. So that's all the questions for now. Back to you, Robin.
Okay, so yeah, all of the questions are answered. So the last thing to do is we would like to say thank you for joining our session today. And before we finally close our breakout room now, please consider or please have a look at our area here. We have here a get in touch field. You can use this to send us questions, ask for demos or anything else. And please also explore all of the other areas that we have in here. There's a lot of content to discover, and I think you will, or we think you will really enjoy this one. Okay, so now we are at the end of our session. The only thing left is to say thank you for your attendance, and we hope to be in touch with you soon.
Thank you.
Welcome back from your breakout sessions. We trust you've gained valuable insights. As we move into our roundtable discussion, we are eager to address your burning questions. Please share them in the chat. I am pleased to introduce the panel members for today's session. From left to right, Mike Rubenthal, our General Manager WaterJet, joining us virtually from the United States. Sarah Mansell, our Director, Product Marketing and Strategy for WaterJet. Erin Vondergon, our Product Marketing Manager for WaterJet. Robin Tyndall, leader of our Environmental Stewardship team. And Ivan Kondakin, our Territory WaterJet Sales Manager for Southern US, also joining virtually from the United States. Welcome, everyone. We have received some very interesting questions during the registration process, and we invite more questions through our chat feature. Today, we aim not just to answer, but to spark innovation, foster new perspectives and connections leading to solutions. By the end of this session, we hope to highlight key industry challenges. So let's kick off with our first submitted question. What are the common applications where WaterJet is used? Are there materials only WaterJet can cut? Ivan, sounds like a question for you.
Sure thing. Great question. Yeah, WaterJet is, it's one of those Swiss Army tools that a lot of shops require mainly because it can do anything and everything. You know, one of the most common applications is obviously metal fabrication, right? Any kind of shop that has any kind of metal work, you know, easy to operate, easy to go from the napkin sketch to a cutting process and then to complete product. Whether it's the first op in the whole process of the component or it's the only op. Aerospace is another huge industry with a lot of components being produced on the water jets. Matter of fact, water jets are one of the preferred methods in the aerospace world because of water jet allows for the no heat affected zone cutting and obviously a lot of materials that are affected by it, such as titanium, stainless, aluminum, Inconel, and such. And high precision of it as well goes a long way with a lot of the aerospace companies. A lot of glass cutting, whether it's decorative or art type work, and not just straight line glass cutting that you normally get with traditional glass cutters. You can do complex shapes, different types of glass, different thicknesses. So that is very common. A lot of laminated glass, similar to bulletproof glass with layers, other different layers, you know, like plastic and stuff in between. We have some cell phone glass application out there. A lot of you carrying your cell phones in your pocket that has Gorilla Glass on it. So there's companies that are cutting those shapes as well. Stone cutters, tile cutters, you know, granite countertops, marble countertops, different tile mosaics with complex shapes and geometries. Once again, being compared to, for example, saw cutting. Saw cutting might induce some chipping and some cracking where water jet can come in and easily cut those shapes and produce high volume of those mosaic pieces. We have a lot of equipment in rubber gasket type manufacturing. In this particular case, it would be a water only application where no abrasive is required. Some of the benefits here is, you know, water jet doesn't get dull like knife cutters, for example, would. It also allows for stacking of the material, giving you faster production times. So instead of cutting on a some sort of a blade cutter, one sheet at a time, here you can stack 5, 10, 20 sheets at a time, depending on the material, and cut them all at once. As well as foam products. So if you think about foam packaging, shadow packaging for you know, cases for different equipment, a lot of that is done on our water jets as well. Some textiles usually would be water only cutting. Once again, being compared to knife cutters, water jet doesn't get dull. It can do all kinds of complex forms. We have a lot of folks cutting composites, G10, G14, carbon fibers. Composites tend to be fairly hard to machine with traditional methods, dulling tooling, pulling strands out of the composites, where water jet can easily pierce them, you know, avoid delamination, and then cut more complex shapes and very intricate details in it as well. We have some machines in food processing industry where a lot of stainless being cut along with rubberized type belts for conveyors, bracketry, things like that, where things have to be obviously very clean, preferably with no, once again, burnt edges or heat affected zones like you would get from plasma and laser. And then, I mean, really, at the end of the day, any kind of weird material. Water jet is not limited by what materials they can cut. So multi-layered materials, glued materials, laminated materials, all of those things is right up our water jet's alley.
Thank you, Ivan. Very versatile technology indeed. The next one is, what are some of the important global trends that are influencing manufacturers today? Sarah, would you please take this one?
Yeah, thanks, Ilyana. So there are a few key macro trends that we are closely following as a global provider of industrial cutting solutions. So one of those areas is automation and digitization. So automation continues to be a necessity for manufacturers due to ongoing challenges with labor shortages. Manufacturers are looking for solutions that reduce dependency on skilled operators. Those skills can be hard to find, hard to keep, and costly. For example, solutions that allow a single operator to run multiple machines or the ability to continue cutting operations after the daily shift are the types of things manufacturers are looking for. They're also looking for improved data and insights about how their equipment is operating. So these could be things like process analytics and system monitoring that help them make data-driven productivity and maintenance decisions. Manufacturers are relying more and more on smart connected systems that self-monitor, self-correct, and enable remote troubleshooting. Another area is sustainability. We heard about that from Robin. Manufacturers are looking to reduce the environmental cost of doing business and increase output for their input costs. They're looking for increased efficiency from their cutting equipment in the form of lower power or water requirements, and of course the ability to reduce, reuse, or recycle wherever possible. So underpinning all of these are the economic and supply chain related trends that we've all experienced over the past few years, and we'll need to continue to navigate as we look ahead. The need to bring down costs, given the significant increase of input and labor expenses over the past few years, and to stabilize supply chains. More and more, manufacturers are looking to increase influence, or in many cases have direct control of their cutting operations through reshoring or nearshoring, bringing production closer to home and under roof. As a global producer of cutting equipment, we are and will continue to address these macro trends through next generations of cutting equipment.
Thanks a lot, Sarah. Mike, I think I've got one for you. So Sarah just highlighted a few very important macro trends. How are water jet systems today addressing those macro trends and some of the typical customer pain points with using water jet?
You bet. Some of the typical customer pain points have traditionally been operator expertise and capability. OMAX has always prided itself on making the software, making machines as easy to use as possible, and certainly that's an overall trend in the industry. We think we've set ourselves apart with an IntelliMax software suite, which precisely calculates feeds and speeds, controls the machine's motion and its speeds. It allows novice operators to create excellent parts right from the beginning. We've continued to enhance those cutting models with ever ongoing research. Certainly another aspect of getting your operators productive quickly is excellent training. As easy as we can make the machines to work, the entire industry, training is a key aspect of having a productive and capable operator. So there's online training that's available, and certainly in-person training, both to maintain the machines and to operate the machines, are pretty critical to addressing some of the issues that our customers have with maintaining capable people operating the machines. The machines themselves continue to get more intelligence with increased sensors and automation. Machines increasingly can shut themselves off when there is a problem. They can send maintenance notices to the customer and to ourselves to let us know what's going on with the machine so that we can get it up and running very quickly, or the customer can. Remote support is in many cases available, where a technician doesn't necessarily need to come in to see if the machine is having a trouble, or if an operator is having trouble getting the machine to do something that they want it to do. We can remotely troubleshoot and address some of the issues. And then there are other features and aspects that we're doing to make the machines able to recover themselves by itself. For example, some new features we've incorporated, such as air sweep, which one of the issues with a water jet on occasion is the jet itself can clog. So making it unclog easily, quickly, efficiently is a key attribute. Air sweep is a new feature that we introduced. We've also introduced other new accessories such as continuous flip feed garnet hoppers that allow us to let the machine run almost continuously. There's garnet removal systems that allow us to take the garnet out of the catcher tank without needing the interaction of an operator. And so those are some of the features that we're working on. I think some of the other shortcomings of the water jet over time have been the fact that it's been perceived as messy, both with water splash, and it's been perceived as a loud and noisy device. So we've got some attributes of our machines that minimize those impacts, such as water level control, which allows our customers to cut parts underwater. This keeps the noise down to a manageable level and keeps the splash down. We've introduced a variety of application-based splash shields over the time, over history, based on what it is that's being cut. We have different splash shields that help keep that mess down and the splash down. And then lastly, the software that I keep talking about, that is a key attribute of our solution. We have different automated piercing routines and different automated cutting paths that minimize the splash. One of the sources of splash is the pierce, or when you cut over one of the supporting members of a water jet. So if you can minimize the times you go over that, or different piercing routines, you can minimize the splash and keep the mess down. Lastly, machines themselves. The water jet is not known as the fastest per se cutting process. While it's faster than EDM, it's not quite as fast as a laser. However, because it doesn't necessarily need secondary processing, overall cycle time can be very favorable. But over the years, we've worked hard to improve the cutting speed of the water jet. And we've done things like continue to improve those cutting models that I mentioned earlier. Today, our machines can cut up certain parts 500% faster than they were able to cut them just 10, 15 years ago. We've enabled that capability to any customer that ever bought a machine from us via free software upgrades. And we've introduced additional capabilities on new generations of machines, such as tilt forward, that allow us to further increase processing speed. So those are just some of the things that we've addressed over the years that have helped mitigate the pain points of the water jet cutting process, and I think address some of the needs that manufacturers today are facing.
Thank you so much, Mike. Got a question for our environmental expert, Robin. Are there any challenges or trade-offs associated with water jet cutting in terms of sustainability that organizations should be aware of?
Right. So as we all know, plasma can generate fumes when you're using a plasma cutting process, but those can be controlled and should be controlled. With water jet, you're depending on two resources, both electricity and water being available. So of course, we encourage use of the water recycling system. You can filter, cool, and reuse your water. And as I mentioned in my previous session, there's a risk when your water use is constrained and you aren't able to get the inputs of water that you need. But then there's also a risk if there's too much water in your environment, or the water table is too high, or the infrastructure can't handle water due to a flood. Then you may be able to use water, but you may not be able or permitted to discharge the water. So those are just risks that threaten your business continuity. And so managing those risks is really critical.
Thank you, Robin. Mike, what are the key economic and environmental as well advantages of adopting water jet cutting technology in manufacturing process?
Well, I think the first advantage is one that's already been mentioned by Ivan, is the versatility of the process. That's what most people attribute to the water jet cutting process, is its ability to cut and machine almost anything. A water jet itself can replace the process of numerous different types of machines. A water jet can drill. It can do the same thing as a CNC mill can. It can cut gears. It can work like a saw. It can take the place of a punch press. It can work like a slitting process. In certain parts, it can work like a wire EDM. It can't produce quite the surface finish or the ultimate accuracy that a wire EDM can. But not every part requires that level of precision, and not every aspect or attribute on a particular part requires that level of accuracy. So the water jet can augment that. Compared to heat cutting processes, it can do the same as a laser, a plasma, or an oxyfuel, but it does that without heat. So that brings us to the second advantage that a water jet provides, is the ability to cut without heat, without changing the properties of the material you're cutting. Ivan already mentioned that. Water jet is ultimately a preferred process in the aerospace industry and defense industry and other industries where not changing the properties of what it is you're cutting is needed. Water jets are certified as a Class 2 and Class 3 machining process in the aerospace industry. So that opens up a whole host of parts on an airplane and an aircraft engine that can be cut with a water jet. Because water jets cut without heat, and because they don't have a big burr, minimal secondary processing is required. Unlike processes that cut without heat with heat, you don't need to grind the edge of a water jet cut surface to have a nice clean edge. Some people believe that the garnet can get impregnated on the side of the surface that was cut. That is actually not true. And if it is a concern, a high pressure jet of water will typically remove that sufficiently so that surface is safe to be used, for example, on a space telescope. So garnet impregnation is typically not a concern for the vast majority of applications. The water jet process itself offers economic advantages versus other machining processes if you're looking for short run or versatile production. Because there's no lateral forces on what's being cut, fixturing requirements and tooling requirements are relatively low. So you can easily go from one part or one material to another one quickly without any elaborate tooling or fixturing requirements. So you can be very versatile and flexible. As opposed to a punch press, there's no die required. So again, small to medium runs can make sense on a water jet. You can nest materials very closely. So you save material by nesting parts very closely. Fragile materials, I haven't talked about the wide variety of materials that can be cut with water jets, such as glass. So you can literally cut glass so close to one another that you can't touch it. It's so fragile that it can't be touched. But those two pieces of glass can be cut so closely to one another that it's an incredible level of precision. And then probably the last two advantages are its ability to cut very difficult materials, alloys, hardened alloys, exotic alloys such as Hastelloy, Invar, Inconel can easily be cut with water jet. As a matter of fact, many people will near net shape cut those parts before they put them on the machining center. That's actually a pretty common application for a water jet. We have customers that can save for cutting titanium parts that go in a jet engine. We have customers that save more than 24 hours of machining by near net shape cutting that part before it goes on the CNC machining center. And lastly, waste is made in valuable chunks. So if you're using it as a near net shape process before it goes on a machining center, you end up with pieces of metal rather than flakes or metal dust or metal shavings. Metal chunks are typically more valuable if you're planning to recycle those, and more easily recycled than those flakes of metal or those chips of metal, and they're not contaminated with cutting fluid. So it offers some significant economic and time-saving advantages. Robin already talked about some of the environmental benefits of water jet. The water jet process is inert. There's no toxic material. So unless what you're cutting is hazardous, such as lead or beryllium, for example, those are two materials that people do cut. We don't advise you cutting those, but unless you're cutting something that's hazardous, the water jet cutting process doesn't produce any hazardous offshoots. There's no dangerous waste being produced. Garnet, the cutting media, is essentially inert. As Robin indicated, it's possible to recycle the water. It's worth noting that a water jet actually uses relatively little water, less than 4 liters of water a minute. but we recommend recycling it when it makes economic sense, and recycling systems are, well understood, well used, and can be economic. And then lastly, one of the other reasons people use water jets is impact on operators, dust and smoke. That's not produced as it is in the case with a thermal cutting process or with even some of the mechanical cutting processes. So you're not putting your workers in a hazardous condition. And by cutting underwater, you're minimizing that noise. So you're improving the overall workplace hygiene and making it a less stressful place for people to work. If you can keep that noise level. In the United States, our OSHA limit is around 80 decibels. And our water jets, when you're cutting underwater, are well underneath that.
Thank you, Mike. One of the common questions our customers keep asking is what are the selection criteria for plasma versus water jet? Arian, would you like to take this one?
Sure. Thanks, Ileana. Yeah, it's a common question that comes up, and as Ivan and Mike have both explained in great detail quite a few of the benefits of water jet. But when it comes into selecting between the two, for water jet, like they've mentioned, it really comes down to versatility. So, what is the ultimate product that the company is trying to produce? Is it a wide range of products? So, like a job shop where they're going to need to cut a variety of materials, variety of parts, perhaps a lower volume of parts, but high variability of it. Or perhaps they're cutting a wide variety of materials as well. So for instance, one day you need to cut foam packaging, for example, and you need a water-only process to, then the next day you're cutting half-inch mild steel for fixturing or jigs or something. It can be used as a manufacturing support tool in automotive applications. So it can be used to provide additional fixturing that's required on an assembly line where that print to part time is really critical to get it to be the operation back up and running as quickly as possible. Plasma is really suited for mild steel, stainless steel, and aluminum. We have significant process expertise within Hypertherm for processing those material types of varying thicknesses. If you're cutting high volumes of parts within those material types, then plasma may be the better option for you, particularly if that's really what you're focused on, and it's in that range up to about 2 inches. But when you are starting to cut thicker materials like that, you can start to assess whether a water jet would be more suitable for that application. They can also be complementary as well, which can help.
Great, thanks, Arian. And I've got a follow-up question right away for you. So what would be then the selection criteria for laser versus water jet? Can these technologies be at all complementary, or are they always compete with each other?
Sure. And oftentimes when customers are approaching us, they always make an assumption that it's one or the other, or it's you have to standardize on a single application or a single technology, but it's really not the case. Well, a lot of customers may start off with a water jet and they cut whatever their production needs are at that time. They may bring on a job or start to bring on multiple jobs where it's that high volume run where they're cutting similar parts in very high quantities and thinner non-reflective materials. And that's really where lasers shine. In that really high production environment, they will cut faster than a water jet and may make more sense. So oftentimes we will have customers that may start off with a water jet and continue to use that for those highly versatile applications where they're cutting the variety of materials, variety of parts, things like that, or thicker materials, and then leverage a laser system for those high production runs.
Yeah, great, thanks. We heard quite a lot already about water jet benefits. Can you share situations where customer issues were tackled, where water jet was the only solution? Ivan, could you please speak to it?
Yeah, sure. There's probably one too many to talk about, but a couple that come to mind. I just recently worked with one of customers in my territory where they manufacture electrical enclosures. And they had a particular run with a lot of pieces that they made for this electrical enclosure where the access door had PLCs that were installed in it. And after they cut everything, bent it, welded, painted it, they realized that the PLC that they were going to put in it was the wrong size. So they had to make the opening significantly larger. And they didn't want to scrap all 3,000 pieces that they made. So that's once again where the water jet came through. They were able to take a already powder coated, formed and welded part. They were able to put it back on the water jet, and without affecting the powder coating and without the need to clamp things or put them in a vise like you would have to on a traditional CNC mill, they're able to secure it in a water jet, come in, simply open up the opening for the PLC, and then just simply touch up the area with a paint pen where the water jet exposed raw metal. And that was it. It was a really painless process. It took less than a minute per piece to modify it. So something like this would be, it would be impossible if it was a plasma or a laser, mainly because the surface is now coated and they simply wouldn't be able to get a good ground on it. Milling is one of the ways to do it, but just the setup time, all of the vices and all of the clamping just would have made it a lot harder, and then also possibly would have affected the finish on the part. Another one that is a really good example, we have a customer that is in a nuclear power industry, and they make a component out of Inconel. It is about 100 millimeters thick, or about 4 inches thick Inconel part. They call it the Spider, and it's actually used to extract control rods from the reactor, and it's a consumable part. So they go through them quite often. They have to machine a lot of them. And originally, when they came to us looking for a solution, they were spending over 28 hours on their mill machining this particular part. And as everyone knows, Inconel is very, very hard, very difficult to machine on a CNC mill. You have to go extremely slow. And especially in this particular case, the part has a lot of very intricate details, which made it even slower to machine. So 28 plus hours, we were able to blank the perimeter of the part in about 7 hours on an Omax. And then after that, it did go back to a machine shop. It did go back on the mill for additional surfacing that they had to do, but it was only 2 more hours of additional surfacing, right? So from 28 hours to combined 9 hours was a very, very significant jump and very significant savings for this particular customer. And now they have multiple machines making just those consumable parts. So yeah, it really comes down to, a simple, complex part doesn't matter. It's the imagination, because of the versatility of the water jet. As long as you can figure out the way to put it on a water jet, it will be a great tool.
Thanks, Ivan. Great examples. Pretty impressive. So cutting speed was mentioned a few times today, right? So what are the expectations of increasing cutting speed and pump pressure with water jet technology? Arian?
Ilyana. Another one question that comes up pretty much every time we talk with a customer is cutting pressure, and there's a couple different cutting pressures in the market that are fairly common, with 4,000 bar or 60,000 psi and 6,000 bar or 90,000 psi. And there's differing viewpoints with it, but when you all boil it down to the pure physics of the water jet technology and the way that that jet stream is manufactured, it really comes down to what is the power that you're drawing out of the wall. So with physics, it's impossible to generate energy through a cutting process. You're only going to be losing energy throughout that process. And so when you really look at the input power going into the system, that's what's going to dictate the maximum cutting speed. And anything from there is going to be a loss of efficiency through the different energy losses of the process. And so when you're talking about it, the really utilization and efficiency of that process is what you need to focus on. So when you talk about pressures, as you increase the pressure, the flow has to decrease, and that's through a restriction or a reduction in the orifice size that's creating that velocity of jet. As that decreases in size, your flow rate is decreasing as well, and as a result, your abrasive flow is decreasing on that. So that's one of the benefits of going up to that higher pressure is a reduced abrasive flow. But what happens when that abrasive hits that higher velocity stream, you can imagine, you know, if you were to throw a penny onto a train track, and a train is going, 20 kilometers per hour, for example, and you throw a penny onto a track and it's going 100 kilometers per hour, that force is going to smash it even more rapidly, or throwing something in front of it and the impact of that. So when the abrasive grains impact the jet stream with a higher pressure jet, they're actually getting more pulverized and losing some of the cutting efficiency of that. Now, oftentimes that benefit is still there with the reduced abrasive flow, because abrasive is one of the most largest contributors to operating cost. But when you look at overall operating cost of the system and you factor in all of the maintenance components and the spare parts costs, the materials required to maintain and hold that pressure at the higher pressures are much more costly. So it ends up being, when you look at overall operating costs, the cost of higher pressure is often offset with that, or the abrasive savings are offset with the increased in spare parts costs.
Thanks, Aaron. Very insightful. Speaking about increased efficiency and productivity, Ivan, could you please share what are some software advances that have resulted in increased productivity?
Yeah, absolutely. With OMAX software, we kind of never sit still with our software, and it's been that way from day one when OMAX was founded. All the way back to the beginnings, both of our founders decided that, using at that time very popular G-code was not the right way to go for the WaterJet software, because it's a liquid tool that we're controlling, right? It's not an end mill, it's not a drill bit. It just doesn't behave the same way. So that's when OMAX IntelliSuda software was born, and we kind of been working on it ever since, and we're continuing to optimize it and make it better, faster. One of the advantages, one of the optimizations tools is how we control our lead in and lead outs. So all of the cutting tools out there, right? Lasers, plasmas, WaterJets, they all have to get into the material and get out of the material, right? We have to pierce the initial hole, we will cut the perimeter, and then we have to get back out of it in a way. And that's one of the things where we learned that, a right distance for a lead-in will give it either a faster pierce time or a slower pierce time. So what OMAX software will do in the background, it will look at how thick the material is, how hard the material is, what settings the nozzles is running at, what settings the pump is running at, and it will automatically either grow or shrink the lead-in to optimize how fast it will punch through the material. And the same thing for the lead out. Sometimes you have to go a little bit further away from the material, not to leave a witness mark, for example, if it's a thicker, harder material. And other times, in the thinner stuff, you can pretty much stop cutting right as soon as you're done with the perimeter of the cut. So all of that happens automatically in the background, and it ends up saving time and increasing the production. Once again, going back to the fact that it's a liquid tool, approaching corners inside corners, outside corners, radius, things like that. You have to watch how fast you go in or how slow you go in. You don't want to wash out the corners or undercut the corners. So that's where OMAX IntelliCorner optimization comes in. It will basically look at the entire part and look at the thicknesses. Once again, look at the hardness of it, and it will make its calculations. And speaking of making the calculations, all of those calculations happen before you even start cutting. As the part is being loaded, OMAX utilizes compute first, move later approach to the software, right? Where all of the calculations are not only calculated to how long it will take, but optimized to go faster and to give better precision and better finish. And then there are sharp corners, right? What do we do with sharp corners? Well, because water jet tends to lag behind as it's cutting, the jet itself tends to lag as it's cutting. Normally, you have to slow down and come almost to a dead stop before turning a sharp corner. And that's where we design corner passing, where we would actually go past the corner and in a way kind of flick the jet forward, allowing for a lot faster corner pass and sharper corner results, which is really, really cool. And all of those things are included in a software. Not only they're included in a software, our machines will come with a lifetime software updates, meaning when we come up with something better tomorrow, customers have a choice to download it, and it is completely free. We also have, in today's world where 3D programming is getting to be bigger and bigger, we offer IntelliCam, which is our 3D post-processor that will allow you to easily grab 3D models and 3D assemblies, and with a single click of a button, it will process it into a cut file that's ready to go. Making it easy, you don't have to go back to your 3D software that you used originally and extract a flat drawing out of it and then somehow process it, and just adds a lot of steps. But IntelliCam allows you to do that. It's an easy button in a way. As well as we work with a lot of the big companies out there, AutoCAD, Rhino, SolidWorks, etc. We work with all of those big players in the software world to make sure they have an easy plug-in for the OMAX machines. Majority of time, those plugins are completely free to those that already have those third-party software programs, and it just, once again, that easy button that will bypass a lot of extra steps and allow you to go straight from your design software directly onto the machine and start cutting accurate precision parts.
Thank you for this thorough explanation, Ivan. I certainly learned something new. Robin, I've got another one for you. How can companies optimize water usage? We spoke a bit about water usage, right? And how can they minimize its environmental footprint?
Yeah, so first, I'm going to touch on what Ariane already said. So that complex interplay between pressure and flow, cost, and efficiency, that's complicated. So definitely reach out to someone at OMAX to understand that better, because you're going to gain energy efficiency from that and optimize your process. But then the rest of the answer kind of comes back to our life cycle assessment. The point of that really is to kind of zoom out your lens and look at the full life cycle from cradle to grave, so that you're not making poor trade-offs maybe based on just what you see. And so the same result holds true that we've already talked about, which is that for other technologies, the #1 environmental impact from cradle to grave is scrap. And so don't lose sight of that. Scrap is definitely going to play into your raw material costs and your overall operating costs. So being able to minimize scrap is going to help the planet, and it's going to help your bottom line. So looking at things like IntelliMax, ProNest LT OMAX, or full ProNest, that's going to help you increase your utilization And as I think someone already mentioned, just the fact that you can inherently nest a little bit more tightly on water jet, that's going to help your utilization. So those are really key for that number one impact. Then the number two impact, we're back to electricity. So thinking of those things we've already heard about. Also things like stacking thin plates to get some extra energy efficiency out of that process. And then the number three environmental impact is abrasive. And the impacts from abrasive primarily come from just transporting it from where it came to you. So ideally, it would be great to source that as locally as you can. That might not be realistic. But again, don't get hung up on that if you can first address the scrap and energy use. And then from the water standpoint, again, right, water is visible and tangible, and it's right there, so you might get a little bit distracted by thinking that that's the biggest environmental impact, and it's not. Like Mike said, from a process standpoint, you're really not using that much water. The most critical thing to look at with your water use is just your own business continuity. So you might not need a lot of it, but if you can, if it's not available, then you're in trouble. And if you can't discharge it, then you're in trouble. So really, it's the risk with water you need to look at. It's not the biggest environmental impact from that full life cycle view.
Thanks a lot, Robin. To close our session, let's talk a little about future. Sarah, could you please tell us, what do you see as the future innovations or trends in water jet cutting technology that will further enhance manufacturing?
Sure. So the future is exciting for water jet cutting. The water jet cutting systems will increasingly become more automated and easier to use, with more process capability built into the software and the hardware. And that will continue to reduce dependency on those really hard to find skilled operators for achieving the desired cutting outcomes and increase throughput of the cutting system. So what will this look like? It'll look like more process capability built into the system, enabling less experienced operators to quickly learn to operate the system, going from a print to a part in a short amount of time and cutting good parts. So you saw from Ariane's session a little while ago, just how easy it is today to produce great parts with OMAX systems, and that's only going to get better in future generations. In addition, increasing automation of water jet systems will allow manufacturers to spread operators across cutting systems, helping to reduce labor costs and extend cutting time after the shift, increasing productivity of the operation.
Anyone
Mike, do you want to jump in here?
So, in addition to that, water jet cutting systems have become significantly more robust. So you're going to see ever increasing levels of robustness, of reliability, and minimization of maintenance needs as the technology continues to evolve. Augmented reality is something we also foresee, making it easier and simpler to program and to visualize the parts. Especially in small run production, where it's sometimes difficult to visualize what it is you're about to cut. Being able to see that via augmented reality, we feel is going to be a big advantage. The systems themselves are going to be increasingly connected. They already are, but we see increasing levels of connectivity, providing data and metrics, the status of the machine. Allows our customers to predict when maintenance is needed, allows them to know how much their machine is being utilized, is it being done efficiently. It'll be integrated with automated smart factories. We also believe that as we continue going further, machine learning will enable increasing optimization of the cutting model as well as improved diagnostics and support. And then lastly, something that we have patented is our cloud-based cutting models. So while machine learning is certainly great, human learning is something that we really want to be able to take advantage of and leverage. Many of us have talked about the versatility of the process. New materials are always being developed and being introduced into the marketplace. So determining how to cut those, how to process those new materials that might not have existed yesterday, is something that we want to take advantage of. Certainly, our customers can do it on their own today, but the thoughts and the abilities of 10 or hundreds of customers allowing us to update the cutting model in real time gives us some further advantages. It also potentially allows us to offer a service that can let our customers optimize a part and its production based on their business needs. For example, if their machine isn't really especially busy, they might choose to optimize the cost of producing that part in the interest of how fast it can be produced. Or if they're facing a lot of work that's going through their operation, they might decide to produce the part at a slightly higher cost in the interest of producing it in a faster or a lesser amount of time, so make the part faster. So we see that as something that's on the horizon. Those intelligent cutting models that are not only intelligent based on machine learning, but based on human experience and our collective customers' expertise.
Yeah.
Sarah?
So there's a lot of exciting innovation coming to water jet cutting in the next generations of cutting equipment that will help manufacturers increase throughput, reduce dependency on skilled operators to produce good parts, and avoid unplanned downtime so that they can even more quickly turn concepts into creations, prints into parts, and improve profitability.
Thanks, Sarah and Mike. Sounds like exciting future indeed. Thanks everyone for participating and sharing your valuable insights.
We are at the end of this amazing two-day virtual session, Shop Talk Live. To all our participants, you all helped to make this a remarkable event. We at Hypertherm Associates are truly honored to have been part of this journey with you. Please let us know how you experienced it by leaving a comment in our chat.
Throughout the course of this global event, we have shared knowledge, experiences, and ideas that have the power to shape our future. The panel discussions generated conversations, and the interactive sessions enabled us to learn from each other.
Thank you all again for your participation and your interest in the topics that were part of our first Shop Talk Live. We hope you implement the ideas that were shared, and be sure to frequently visit Shop Talk, our 3D platform, for helpful information that you can access anytime you need it, and the recorded sessions.
We wish you all the best in reaching your goals and objectives, and please let us know how we can help. Stay tuned for the next Shop Talk Live event in 2024. And for now, goodbye and thank you.
Thank you.